inverse trigonometric functions. Okay? You guys are familiar with trigonometric functions. And if you're not, make sure to look at the videos on this channel. We now talk about the inverse of a trigonometric function. Now, the way in which I like to describe this is in reference to addition and subtraction, multiplication and division. When I ask you what undoes addition, you'd say, oh, subtraction. You're correct. When I ask you what undoes multiplication, you say, oh, division. Correct. Now, what undoes taking a function? Because that can be thought of as an operation. Just as adding two numbers is an operation, taking a number and taking that function value of that number, or as we call in mathematics, evaluating that value. For instance, let's say we have the number 3, then what is f of 3? Well, I can't tell you until you define what f of x is. Well, let's define f of x to be x squared. Then, it's no longer ambiguous what f of 3 is. F of 3 would just be 3 squared, if that's our f of x, which means it's equal to 9. So evaluating a function is an operation on the number 3. So, what is the inverse trig operation? So, what if I have sine of theta, okay, that equals some L. It's a length. Sine of theta is a length. Usually, as you know, it ranges from -1 to the range of sine is from -1 to +1. Okay. So this L is some value that is inside there. So it's either -1 or +1 or anything between. You know the special values on the unit circle. So what would undo taking the sine of theta? Well, we call this the sine inverse of theta, where sine inverse of sine of theta is just equal to theta, and on this hand side, that results in sine inverse of L. So what does this mean? Well, it means, we know, for instance, that the sine of pi over 4 is root 2 over 2. This is our length we're talking about over here, L. This root 2 over 2 is the length. It's the sine value at pi over 4. So how do we undo this situation? We take the sine inverse of both sides, sine inverse. When sine of inverse hits sine, it disintegrates, leaving only what's inside the parentheses, just pi over 4. So pi over 4 is precisely sine inverse of root 2 over 2. Aha! So whenever we take the sine of pi over 4, I'll write that over here. So when we say the sine of pi over 4, we input angle, it outputs length, root 2 over 2. Notice that sine inverse of root 2 over 2 is equal to my pi over 4. So the input becomes the output, and the output becomes the input. Okay? That is what taking the inverse sine is. And I'm telling you that it's a function. Meaning, we have to construct our inverse trigonometric functions in such a way that they will too also be functions. How do we determine whether something is a function or not? Well, we know a function is a function if it passes the vertical line test. So let's talk about the graphs of sine, for instance, and then we'll talk about cosine, and then we'll talk about tangent. So I need to clear up some real estate here. Notice that if we create a table, sine of theta versus theta table, that we will have some values associated with that. Let's say theta is 0, theta is pi over 6, pi over 4, pi over 3, pi over 2, for instance. Fix this real quick. It's kind of difficult to see. Fix this real quick for you. Try it again. Sine of theta, theta. So we'll have 0 as our angle, pi over 6, pi over 4, pi over 3, pi over 2. Okay? So what is the sine of 0? You already know by watching my videos on the unit circle that the sine of 0 is 0. And you haven't memorized it, you understand it. And you know at pi over 6, it becomes a 1/2. And you know at pi over 4 is our familiar root 2 over 2. At pi over 3, it becomes root 3 over 2. And at pi over 2, it becomes 1. Very good. Now, let's talk about sine inverse. Okay? Let's now compare this to the sine inverse. So we'll extend these values here. And we have right here our sine inverse of theta. Okay? So, actually, we can't say theta anymore because sine inverse does not like to eat or evaluate angles. Sine inverse likes to evaluate lengths. So I'm going to say sine inverse of an L, where these outputs, these are our L's. Over here, this whole column is an L. So over here, sine inverse of L is sine inverse of 0. And this is sine inverse of the length 1/2. And this is sine inverse of the length root 2 over 2. This is sine inverse of the length root 3 over 2. This is sine inverse of the length 1. Okay? Now, we must determine what is the sine inverse of these values. Well, notice what we just erased. For instance, we have the example, what is the sine of pi over 4? We know that's root 2 over 2. Meaning, if the sine inverse is truly the inverse function, just like in pre-calc, then sine inverse of sine of pi over 4 is equal to sine inverse of our root 2 over 2. Okay, according to that calculation, we're going to take the sine inverse on both sides. The left-hand sine, sine inverse composed with sine, the composition of those results in just a pi over 4. Which then we set that equal to our sine inverse of root 2 over 2. And so that's what the value is. So already I know over here, this should be a pi over 4. Notice this is a pi over 4. Do you think that's a mistake or a coincidence? It is actually not a coincidence. If you know the sine of pi over 4 is equal to root 2 over 2, then you know that the sine inverse of root 2 over 2 is pi over 4. This is the calculation right here that we've done here. So doing a similar calculation for each of those rows gives me that the sine inverse of 0 is 0, sine inverse of 1/2 is pi over 6, sine inverse of root 3 over 2 is pi over 3, sine inverse of pi over 2 is 1, pi over 2, okay? And now we can plot the sine inverse just like any other function. We can create what we would say an L axis and a sine inverse of L. Remember, L stands for length, okay? So now, we'll have to determine what the domain of this new function will be and what the range of this new function will be, okay? They say hindsight is 20/20. And so, with hindsight, I'm going to tell you that the domain of sine inverse and the range are the following. Sine inverse has the following domain and range. its domain is what the range of original sine was. Because sine of theta has domain and range. Its range is -1. Its domain is actually all real numbers. So it's flipped. The domain of sine inverse is now what the range of sine was. So would you guess that the domain of sine inverse is now the range of sine, -infinity to +infinity? Actually, no. Because if that were the case, it would fail the vertical line test. We will see that the range is actually from -π/2 to π/2. Hence why I've labeled it right here, -π/2 to π/2. And here's why. Whenever we plot these values here, if this is the L-axis, my inputs range from 0 to 1, and I have these various outputs here. So over here, this will be π/6, π/4, π/3, and that will be our π/2. At 0, our sine inverse of 0 is 0. Sine inverse of 1/2, so here's 1/2. At 1/2, it is π/6, so right here we'll put a dot. Then at √2/2, it's π/4. Over here, √2/2, we'll be over here at π/4. And over here at √3/2, it's at π/3. And at π/2, it becomes a 1. Similarly, for the negative values, it will do the same. So it looks like this. Okay? And my dots have not done it justice. Usually it will kind of have a more curvy nature to it. So it'll kind of look like this. Like this, and like this, where it ends right here. This is at 1, π/2, and this right here is at -1, -π/2. This point here and this point here, respectively. Okay, and we say we stop there. The range now stops there. Why? Why? Well, think about it. If the sine wave were to continue, and I'll do so in a different color, red for danger. If the sine wave were to continue, it would do this. And it would do this. Notice that such continuation would cause this range to go from -infinity to +infinity, flipping the domain to where the range would be. Okay? So then notice that it would fail the vertical line test very horribly. Failure of the vertical line test because it would touch it here and here. And so we have to restrict the range to -π/2 to π/2 inclusive with brackets, because otherwise it would disobey the vertical line test. Notice the vertical line test would not be disobeyed if we only have the black. But when the red gets involved, it would disobey the vertical line test infinitely. So what we do is we restrict the range of sine inverse. And so now, from this video, you know what sine inverse is. It's a function, precisely the inverse function of sine, and you know how to compute any values of it. So now we've also graphed it and discussed why it's a function and determined what its domain and range is. Next, we will do this for the other trigonometric functions, cosine, and even for a tangent. And we'll discuss more about their nature and some practical problems on how to do them. Thank you very much.